Hello, everyone. Lovely. Okay. Welcome to the webinar, and thank you very much, Stephen, for the introduction. Dermot McElroy is my name, and I work in Heat Pumps Ireland, which has been in existence for the last 15 years as a heat pump importer and distributor and supplier to the mechanical industry and the plumbing trade in Ireland. Just move on to my next slide, just covering what I'm going to speak about very briefly today. I'll just talk a little bit about our company, about heat pump systems themselves and what they are. For most people will probably know already or are well briefed in what they are and what they do, but I'll talk about them very briefly. I'll just talk about the types of heat pump system available, or the ones that we supply, certainly. I'm just going to talk a little bit today about the retrofitting side of things and what to do to dwellings, or what types of dwellings would suit a retrofit for a heat pump system or any type of heat pump system, and what to consider when you're trying to make that decision. And then for anybody that might have a question afterwards, we can I'll take a couple of questions on what I know about heat pumps in my 15 years experience to date. So as I said, we've been supplying heat pump systems since 2007. Primarily, we started doing geothermal. They were really the only heat pumps that were supplied on the Irish market at the time. We did mostly Swedish systems for the first 6 or 7 years that we supplied heat pumps into the trade. We do and did, as we did at the time, both residential systems and commercial systems, and we supply heat pumps for both the new build and the retrofit industries. We do, primarily you have two main types of system: an air-to-water system and a geothermal system, which I'll talk about those in a little bit. We train plumbers here in our facility in Dundalk as to what they are and how to fit them, and the do's and the don'ts of heat pumps. We have been supplying Thermia, which is a Swedish brand of heat pump, for the last 13 years. And recently, in the last couple of years, we've also supplied to the same client base or customer base, Mitsubishi Systems, who have primarily an air-to-water range only, but within the air-to-water, they have a far broader range of products, including a very broad range of split systems as opposed to monoblocks, which are what the Swedish companies typically supply. So for us, one of our key selling points to anybody, either in the trade or from an end user point of view, is that we give very good backup and support on what is a very technical product when it comes to the knowledge level needed to install these products. We commission ourselves every system that's supplied and fitted in this country, and we give very good end user support because heat pumps aren't boilers. They don't work like boilers or run like boilers, even though they do exactly what a boiler does. But sometimes the controls and the setup of them can be a little different to a boiler. So for us, it's very important as a company selling these systems that people have a good comfort factor when they're using them. They're not intimidated by them as a product, because there's still a certain fear factor level with them as to what they are and how they run and how much electricity they use and what have you. So for us as a company, end user support is extremely important. Again, and this is just for a very brief discussion, a heat pump system does exactly what a boiler does. It heats the water for your radiator system or your underfloor heating system, and it heats the water in your hot water cylinder. So it does what a boiler does in its core function. It runs on electricity rather than a fossil fuel, which is its primary difference. So your oil or gas bill goes, and now your heating and hot water is transferred to your electricity bill. So that's probably key difference number one. As a lot of people use the comparison, a heat pump works in the same technology as a chiller or a fridge or a freezer. There's the same evaporation and condensing process using a refrigerant gas. So although people think heat pumps are quite new technology, the core technology in the heat pump has been here for 80 or 90 years. And typically, as a fridge blows warm air out the back when it's chilling food, a heat pump creates hot water to run through a heating system using exactly the same process. The core thing we mention to people when it comes to installing a heat pump is that a heat pump will always save money against an oil or gas boiler where there's a high demand for heat in the building, or the building is occupied a lot. If you run a boiler for an hour a day and that's all you really want to do, or an hour in the morning or an hour at night, a heat pump may not necessarily be a good product to replace a boiler, because a boiler can run in a very stop-start manner, whereas a heat pump is far more about constant background heat. So always good savings on a heat pump system if you're using your boiler a lot, but less so if you're not. And the last point, because people always ask about maintenance on systems and are they high maintenance product? There's no combustion in a boiler. There's no burner or flue or flame or residue to clean when you have a heat pump system. So typically the maintenance on a heat pump is simpler and cheaper. There are three primary types of heat pump system available on the market. You have air to water systems, which probably represent 90% of all heat pumps sold in this country. You have geothermal, which 10, 12, 14, 15, 16 years ago dominated the heat pump market, but they're typically for new builds only. They don't really suit retrofits unless you're excavating around your existing lawn or garden. They're a more costly installation, but can have some benefits, which I'll touch on in a minute. You have air-to-air systems, which a lot of the larger companies like Mitsubishi would supply, where you're effectively air heating rather than water heating, but you can also typically do cooling and heating their products based on air conditioning systems with a cassette on the wall or ceiling where warm or cold air is blown out into the dwelling. They don't heat water per se, so you need some other means of heating hot water for showers or taps, but they're a growing product in the, say, apartment retrofit market where you might have storage radiators that you want to get rid of, and you're looking for something else to heat the building other than what are quite expensive old technology storage heaters. So there's a fourth system there, which is exhaust air. We don't actually supply those systems, but they are becoming more common in certain developments, probably more so in the capital than anywhere else. But the first three there are the three primary systems that are supplied in this country. As I mentioned at the start, when it comes to looking at the installation of a boiler, replacing a boiler versus a heat pump system, your first main consideration is that a boiler runs on a fossil fuel versus a heat pump running on electricity. So you can get rid of your oil tank, get rid of your boiler, or get rid of your fossil fuel supply if it's gas or mains gas or LPG, and you're going to install a system which runs on electricity. So your electricity bill will go up, but your fossil fuel bill will be eliminated. A heat pump, for the most part, runs at a lower temperature for longer periods of time. So if you retrofit a heat pump to your house, you'll notice that in the heating season, your radiators run at a 30-40 degree temperature for longer periods rather than a 50-60 degree temperature, which typically comes on and off in a stop-start method on a time clock. So you're not just going to have heat coming on from 6 to 9 in the morning and 12 to 2 or 5 to 8 at night. Typically, a setting will be programmed into the controller of 20 degrees or 19 or 21 or whatever you set your master temperature at, and the dwelling will probably hold that temperature for most of the day. So that's a very, very key point to take into consideration when looking at a heat pump system. So as I said, not stop-start, more constant background heat. Typically, a boiler will suit any building, whereas heat pumps really are only retrofitted to buildings with a decent insulation level or decent glazing level, or a relatively higher C or B rated BER level. They don't really suit poorly insulated buildings or single glazed buildings. Anybody looking at a heat pumper who will inquire about a heat pump retrofit, we tell them to go back and look at the shell of the building and its insulation level and then look at a heat pump afterwards. So it's sort of, you know, you'd look at insulation first and heat pump second rather than the other way around. Again, a heat pump suits a high occupancy level building. And by that, I mean a building that's occupied a lot during the day, where typically the boiler would have been running, you know, mornings and afternoons, as well as early morning and evening, so that you're getting the benefit of a system that's providing constant background heat. And typically when we are commissioning and programming heat pumps, we set them up in such a way that they react automatically to changes in temperature, because for most people, the controls that come with a boiler and the stop, start, boost, on, off, immersion switch, control mechanism is all done away with, and we leave the system in an operating mode that as the weather gets colder, the system ramps up. As it gets milder, it ramps down. You come into the summer, it turns off heating altogether and just does your domestic hot water. And so it saves you having to fidget with, as I said, boost and advance and stop start buttons all the time. And that in itself is good for people who, you know, needed to get a plumber or an electrician out to change the controls, or anytime they wanted to move it from winter mode to spring mode. And it's a big plus in most heat pump systems that come with what's called a weather compensation option, so that you can just set it and leave it accordingly. There are huge incentives nowadays to retrofit heat pumps, not just from a green or save the planet reason or basis. You have SEI have at the start of this year hugely increased the residential grant to put a heat pump in your house. You have a grant of €6,500. That's quite straightforward to apply for in terms of the application process. For your house to be applicable, you have to meet a certain level of insulation and glazing criteria, which is defined by a technical assessment, which is carried out by an advanced BER assessor who looks at the house to see is the insulation and glazing and shell level suitable to retrofit a heat pump, i.e. will a low temperature heat pump heat the house. But, you know, for houses built probably since the early noughties, or anybody refurbing the house and pumping cavities and upgrading glazing, they're a really, really good idea. You know, the heat pump in turn will further enhance your BER and probably the value of the house to boot. When they're fitted, as I said, the heat pump maintains the building at quite a steady temperature. You have a lower temperature running through radiators. Sometimes people put their hands on radiators after the system is installed and wonder how that low level of heat is keeping the building warm. But a heat pump is all about temperature maintenance rather than stop start. Similarly, the cylinder, your hot water cylinder, where you have your which feeds your showers and baths, it's also maintained at a 50-55 degree level, so that every time there's a shower or a bath in the house or water is drained from the cylinder, the heat pump controller picks up that the cylinder has dropped in temperature, and it will reheat the water back up to the temperature programmed into the controller. So you don't have to worry about, is there enough water for the next shower or bath? The system will reheat the cylinder automatically. And again, as I've repeated, but it's a very important point when looking at a retrofit. You know, if you're working from home, if you're just retired, or any building where there's people in the house morning, afternoon and evening, a heat pump is a great idea, because it can provide a constant level of heat in the building efficiently against what a boiler will cost to do the same. A boiler can be turned on for a couple of hours a day and kept at a relatively low fuel consumption cost, where a heat pump doesn't really operate like that. It's really for a constant background heat, without sounding like a parrot here. So again, really a good idea for high occupancy buildings. Couple of other primary differences to consider between an air to water. An air to water can be retrofitted to any building. It's a unit that sits like the display model on the left, that sits inside a building, and then you have a number of different indoor options, cylinders and controllers that have to go inside the building. But typically air to waters can be put in any small residence, large residence, new building, existing building, commercial premises, factory, whatever. And that's probably why they're the most common system available on the market today. Geothermals are a different type of heat pump, albeit they do exactly the same thing. They heat your underfloor, they heat your radiators, they heat your hot water cylinder. Primary differences are, one, not really a retrofittable product because there's so much civil works or groundworks to happen outside the building. And you're either, as the image represents there, you're either drilling a borehole or digging trenches all around the building to bury pipes in the ground, which are in turn the energy source for the indoor unit. And but aesthetically, or from a visibility point of view, you don't actually see anything outside the house. And for new builds that we would supply where there's a large amount of glazing or landscaping or patio areas or whatever, where they may not want to see an outdoor box, with the geothermal, there's nothing visible outside. And as the heat pump itself is located inside the building and not exposed to the wind and the rain and the elements, a geo system typically has a longer lifespan because it's sort of immune from any external air corrosion or anything that might give more wear and tear to a unit that's outside. And typically, if you have a building very close to the sea, a geothermal can be a good idea, albeit more expensive. For most one-off houses, a geothermal system could be 4,000 or 5,000 or 6,000 euros extra on top of what an air-to-water system would be. But if you take a longer-term approach, they can be a better option. And from an aesthetic point of view, as I said, there's nothing to see outside the building. So that's my very brief run through on Heat Pumps Ireland, what we do, the types of systems that are out there, the retrofitting of systems, which is probably the fastest growing sector of the heat pump supply chain at the minute, to such a degree that there's nearly a shortage of product on the market. So most of the guys within the Heat Pump Association or within the heat pump import and distribution industry are struggling to get product at the minute, such as the demand for them and the grants available for them. But for the reasons I mentioned already, they're a really good idea to retrofit, particularly in decent buildings with a high fuel requirement where the boiler is running a lot during the day. And that's me. That's my little presentation over. So I will dial in Stephen again there to see if anybody has any questions on what I said. And again, Stephen, thanks for the invitation to speak here today.
Thanks very much, Dermot. That was perfect. There's no questions so far. I don't know if there's anyone in the audience have any questions. We'll give it a couple of minutes. We have a couple of minutes anyway. But yeah, it's interesting that, you know, as you're saying, that there's a supply issue really at the moment, because again, all the different targets around Europe. I envy and don't envy heat pump suppliers around Europe at the moment, because there's such a demand from, and you know, just trying to get that supply out it's a Herculean task when you think about it.
For sure, yeah. It's I mean, the green wave and the green energy wave for the last couple of years has really hit home to people and driven the level of consciousness up in terms of the general demand for heat pump systems. Obviously, the large grants we have in this country further boosted the demand in Ireland for heat pump systems. The residential boom added on top of that. So heat pumps are fitted in virtually every new building in the country at the minute. And then if we didn't have all that to play with, we had the Russian invasion earlier in the year of Ukraine, which gives the challenge to a lot of countries who are heavily dependent on Russian gas of looking for an alternative heat source. So a lot of countries in mainland Western Europe who were predominantly relying on Russian gas rushed to source heat pumps as a supply of heat residentially and commercially. So you have 3 or 4 factors that all kicked in this year that meant that a lot of wholesalers and installers and mechanical contractors bulk bought product to have them, which moved the supply shortage up the food chain. And yeah, it's certainly, most of my colleagues in the association are spending more time allocating product than looking for orders, and that's the way it is. As you say, it's a good thing in one way, but you're spending time apologizing to people as much as selling to them at the minute. And But no, it's a challenge that's probably going to remain well into next year and possibly into the year after that. So forward planning is the way to go for any building that you're looking at the minute.
Makes sense. Yeah, yeah. And just there doesn't seem to be any questions. Just a question, I suppose, from I'm just thinking about the people I know that are looking into heat pumps. Like, what is the general kind of estimated cost you'd be looking at between air to water and geothermal kind of system?
Yeah.
Whether
Well,
it be borehole or.
Sure, I'll give a couple of quick figures there. If you take an existing 2,000 square foot house or 200 square meter house that's up to grant level and you're retrofitting a heat pump system, you'll probably spend 13,000–14,000 euro to do that, or somewhere, depending on difficulty to pull out the boiler and flush out the radiator system and all that sort of stuff. So that's a cost to dig out boiler, to get the hot water cylinder, flush out the rads, fit a new cylinder, fit the heat pump and wire it in. Smaller house maybe less, bigger house maybe more. If the radiators are too small, and probably even maybe too small for the boiler in the first place, radiators may have to be changed in the building. So that will add cost from a retrofit point of view. Geothermals aren't really a retrofit product, so I don't really talk about them from that point of view. But the grant typically for a lot of dwellings can cover 40–50% of the cost, you know. So you're outlaying, let's say, 14,000 euro for want of a description, and you get 6.5 back, leaving you with a 7,500 euro outlay. You know, obviously bigger houses with bigger kilowattage systems need bigger heat pumps and bigger cylinders, so the cost is more there. When it comes to geothermal in a new build, the cost might be similar, you know, maybe 10, 11, 12,000 euro to install a heat pump in a house, whereas a geothermal, because you have that hardware cost plus the cost to dig trenches or drill boreholes, you'll add somewhere in the region of 4,000 to 5,000, maybe to 6,000 euros onto the cost of the system. So a geo system in a new build, before you get into radiators or underfloor heating, can be up on 20,000 euro. And, you know, so it is a substantially larger outlay. But again, if you're building a house that you expect to live in for the next 30, 40, 50 years, it's something you have to look at from a long-term point of view. The main benefits of them, nothing visible outside, they last longer, and in colder weather, their efficiencies can be better because their energy source is the ground, which is always plus in temperature. Whereas an air to water heat pump has to run whether it's +5 or -5. And the lower the air temperature, the harder it is for the compressor to generate heat with an air to water. Whereas typically a borehole will always yield 6 or 7 or 8 degrees, and a horizontal collector, even in midwinter in the right ground, will be 3, 4, 5, 6 degrees. So I would say to people, if your budget's there, do it. And if it's not, you still have a brilliant range of air to water systems that will suit your house.
That's perfect. That's perfect. Well, thanks very much, Dermot, for that, and great insights as well. And thanks everyone for joining us as well. Join us again tomorrow. We'll have Unitherm heating systems. They'll be talking through their products as well and giving us some more insight as well. And again, as I said, special thanks to Dermot today for the excellent webinar. And hopefully we'll see more in the future. Thanks again. Thank you, Stephen. And thanks everybody for listening. Thank you. Have a good day. Cheers. Bye bye. Okay. Bye. Bye bye.